Welcome back to Workplace 30. We'll start with reading Math on the Job on page 167. This is for section 4.3, Odds and Probability. Note that this is the last section of this chapter. So after this, we'll be doing a chapter project, and then a review, and then your exam will be coming up. So we're talking here about odds. If you have 56,000 raffle tickets that are sold for a fundraiser prize, what are the odds that a person with one ticket will win? How about if that person buys 4 tickets? So if that person buys 1 ticket, their odds would be 1 in 55,999. Note that these two, both of these, have to add up to your total, which is 56,000 when they're added together. So if you buy 4 tickets, your odds would be 4 in 55,996, because again, these two have to add up to 56,000. You can always reduce these ratios if possible, and it is expected that you will reduce them as much as possible. So your final answer is 1 in 13,999. So now what are the odds against this person winning? So what are the odds of not winning compared to the odds of winning? So for 1 ticket, the odds of not winning are 55,999, and the odds of winning are 1. Whereas if 4 tickets, the odds of not winning are 13,999, and the odds of winning are 1. Then you can explore the math on page 167, and copy down the following definition. Then let's look at example number 1. Here we have a television station that's hosting a contest. Alice can choose one of the 7 doors to open. She'll win whatever prize is behind that door. So there's 7 total possible doors, and these are your options that she could win. So what are the odds of choosing the door with no prize? So you'll first start by writing the number with no prize. So that is 1 door. Then you can also write as a ratio compared to the number of doors that have a prize. So 1 to 6 would be your odds. Note that if you add these together, 1 plus 6 equals 7, which is your total. B, what is the probability of choosing the door with no prize? So probability is always written as the number of possible outcomes over your total. So 7 is your total. So you'll write 1 over 7, or as a decimal is 0.14, or as a percent is 14%. So those are your options for probability. Note that the odds and probability do not look the same. Odds are written as a ratio, probability is written as a fraction, decimal, or percent. C, what are the odds of Alice winning a gift certificate? So gift certificate, there's 2 possible prizes. So there's 2 chances that have gift certificates and 5 that don't. So 2 to 5 would be your odds. Example 2. A tire manufacturing company does random testing of tires coming off the production lines to ensure that they are being produced correctly. After testing, the quality control manager calculates the experimental probability of the tire having a defect is 0.003. Now we can write this as a fraction of 3 over 1,000. So that would be your probability. To rewrite the odds in favor of a tire being defective, we need to take the number that are defective, so 3. So 3 are defective, and 997 are not, because these two, again, have to add to 1,000, because 1,000 is our total listed there. So what are the odds then against a tire being defective? So then we're taking the odds that it's not defective compared to the odds that it is defective. So you need to pay careful attention to the wording. C, what are the odds in favor of a tire being correctly manufactured? So this is actually the same as B, but it's asked differently. Here we're considering the number that are correct versus the number that are not correct. Turns out to be the exact same odds as the previous question B. D, in a production run of 30,000 tires, how many tires would you expect to be defective and non-defective? So you can set this up as cross multiplication. You know that 3 and 1,000 are not defective, so you can set this equal to x over 30,000. So you find that x is 90, and that's how many defective you have. Then to find how many aren't defective, you'd take 30,000, subtract 90, and get your answer here as being not defective. This next question comes directly from the curriculum and it's not on your student handout. Critique the following statement. It is not possible to express odds as fractions. So if you take the ratio of 1 to 4, a ratio can always be rewritten as a fraction, but the probability of this same statement is 1 over 5. So you'll note that these two fractions are not the same. So yes, it is possible to rewrite the ratio 1 to 4 as a fraction, but that will not mean the same as the fraction given in the probability. So please keep that in mind. Then you have an assignment, page 172, number 1 to 4, to work on.